Hi. Thanks all for coming. Tonight I'm going to be talking about Realm or Realm.io, and Realm is intended to be a kind of replacement for SQLite. Who's using SQLite in their Android apps? Come on, like, be honest. Okay, who's using Realm? Okay, cool. Alright, I can understand. Yeah. Yeah, SQLite. So when I first started working at SQL, one of the decisions I had to make was what database solution to go for, and I was just looking through all the SQLite stuff, all the libraries, the ways you do things, and there's just so much stuff you have to do to get SQL working. It's like SQLite's like a motorcycle. Like, it's all manual. It can be fast, but if you fall off, you break every bone in your body. Whereas Realm is more like kind of a really nice Tesla. Everything's kind of in there. You've got seat belts. You've got a computer that drives for you and very, very rarely crashes. And so tonight I'm just going to kind of go through some of the things that you would have to do in SQL and then compare them to how you would do them in Realm. So some things like how you do kind of your data modeling, object mapping, queries, updates, a little bit of performance, because everyone likes performance, change notifications, and how you deal with threading. And so we're just going to go through each of these kind of one by one. So SQLite data modeling. I find this quite painful, mostly because we have to define strings for each of our columns, and then we have to extend this helper class, and we have to set up the database, and then we have to write the create table logic, and all this is just strings. So if you misspell something, there's nothing really to stop you there. There's no real protection until you're falling off the motorcycle and going grazing across the turf, and the only thing you've got is your Kevlar jeans to protect you. And on upgrade, it's just this is what I want. I just want this. What is all that other stuff? It's just madness. You can get some libraries to help you. I think SQLite, I think, is a really good one. There's a few annotation processes that will help generate a lot of that boilerplate, which you've gone through, four slides of boilerplate. And this is a pretty high resolution projector, so that's a lot. And whereas data modeling in Realm feels like this, for me, it feels like the future. And you may notice that I've got lots of Futurama slides because I'm somewhat obsessed with Futurama, so bear with it. So there's a lot of them in there. And that's it. A little bit more boilerplate in terms of the models, but there's no setup. We don't have to create the tables. We don't have to tell it what to do when there's an update. We don't have to tell it when it changes. The models have to subclass. That's it. That's our models. And there's no foreign keys or anything. We just say to the post model, you have a user, and we have it. All that connection is there for you, and everything's all wired up. There's no foreign keys to worry about. There's no how to deal with the cascading deletes. Everything's just kind of baked in from the beginning, and it's all there right in the very beginning. So you don't have to do anything. It's all just right in there. Object mapping. Strings. Why are we still using strings? It's 2016, Java is a statically typed language, and we are using strings to fetch data out of a disk on the file. Why? This is just... and... that's all I need in Realm. That's it. Queries. Maybe there's a bit of a kind of picking on SQL a little here, but strings. That's kind of my point here. SQL, we're dealing with strings, like, and we have to do foreign key joins, and that's all I need to do in Realm. I'm just like, I want to find all the posts. Give me all the posts. I don't have to deal with a cursor. I don't have to deal with any of that. It's just, give me all the posts. And if I want to filter on things, well, okay, there are some strings here, so there's an annotation process that gets rid of these, but so okay, so we're not quite getting away from strings just yet, but we'll get there. There's a version 2 coming out soon. It's on the roadmap if you check it. Updates. So SQL, I have to. What is half this stuff doing anyway? Like, I got to get the table. I have to like store values for my strings. I have to like no, go away. It's much nicer. Like, we just start a transaction, we get the thing that we want, and we call the setter on it, and we commit it to the database. Like, that's it. So, updates are kind of, not too bad. So, I'm picking on SQL a little, but, what's that? Really 3 lines of code, so basically the same. So, yeah, some things, why not Zoidberg? It's like, so everybody likes performance. I quite like this one. It's like, you need the speed of light. Why are we doing 35 miles an hour? So SQL feels like me at some point. So queries. So iterating over a record. I think it's like 200,000 items they're iterating over, and we're getting 31 queries a second. So 14 is not too bad. If you're doing iOS, core data is core data. Counts are super fast. Inserts, actually SQL can do quite a lot better. But how often are you inserting 200,000 records into your database? I'm usually inserting like 3 at most. But to give SQL some credit, like, SQL isn't slow. Often the way we're using SQL is slow. In SQL you can do things like you can cache the queries and reuse them over and over. You can, like, this is a little database which I think is abandoned. No one's done anything for like 6 months, and there's like lots of open pull requests that no one's committing on anymore. And the blue is the key value in SQLite. And using SQLite to do a key value database is insanely fast. And I think this library is also doing things like query reduction. So if you're doing a query, so if you're doing 2 writes that perform the same operation, you can do things like just strip out the second operation because it doesn't actually matter. Or if you're doing reads that don't actually interfere with each other, then you can kind of query the database without kind of worrying about too much kind of contention with locking. So you can make SQL run fast. It's not that SQL is slow, it's just it requires a lot of effort from my part and a lot of kind of... Oh, okay, clearly, like, see, this is what I'm talking about, core data, it doesn't understand. Okay, core data is pretty good if you're just getting started, but seriously, use Realm. So, you can make SQL run fast. It's just, you have to make it run fast. Whereas Realm, out of the box, it's just faster in 2 out of 3 of these cases. And 2 out of 3 is pretty good. Like, it's better than a third. Another thing that I've kind of become a little obsessed with is a kind of reactive architectures. And one of the things that I kind of have a problem with in SQLite is it doesn't tell you when things update. The SQLite C API actually has a method that will notify you when a table changes. But as far as I could find out, the Java API doesn't actually expose this. And I don't know if this is because of the version that Android's running or what, but so if you want to do change notifications, you basically have to set up your own event bus or eventing system when you're updating or inserting records to notify someone when data has changed or that there is new data available. So it's kind of like roll your own, so don't ask me about my code. Whereas Realm, we can just attach a change listener to our queries, and when new things come back, it will just tell us when there are new collections of puppies, because these posts are about puppies apparently. And that's it. We don't have to do anything in terms of dealing with the change notifications. And Realm actually goes a little bit further in that we don't actually need to attach a change notification to get new information. In fact, if we just reread the fields of an object, and the object has changed since the last time we read it, it will actually give us that new information. So Realm is smart enough to know that when you're asking for the information again, if there has been an update, it will give you the new information. And you don't have to do anything for this. It's just kind of built in. So we get the username of the user from this post, change it somehow, I don't care, and then reread the value. So you don't even need to use the built-in system. So if you have already events in an application that tell you when the data has changed, you can just reevaluate your queries and you'll get the updated information. SQLite really wasn't built for multi-threading. It's kind of designed as like a single user, single threaded system. So if you want to do your own, if you want to do multi-threading in an application, and often like Android will actually yell at you very loudly if you're trying to do too much on the main thread, and your users will yell at you even louder. So you kind of have to invent your own solution. So we just set up a serial queue, and in this case, just this really naive solution. Our writes block our reads. So when if we're writing lots of data, we can't actually perform reads because we want to guarantee consistency in the database, and to do that, we kind of have to single thread our access to our database. You can do priority queues, which makes it a little bit easier, so you can prioritize your reads over your writes. But again, this is all kind of bring your own internet. Whereas in Realm, everything is just shiny and just all just kind of there for you. And the way this works is magic. No, I'm kidding. The way Realm deals with threading is that your queries are thread confined. So the thread that you request your query on is the only thread you can actually use your query. So Realm, in their own documentation, says you can perform queries on the main thread. And you can. So you can query your entire database of 200,000 items on your main thread, and it will come back in less than a millisecond. And Realm does this by being lazy. So even though it goes, here are your 200,000 objects, it doesn't actually read all 200,000 objects into memory. It just goes, yeah, they're there when you want them. And that's how you can do that thing before where we reread the value to get the username again after we updated it without even using that change listener. Because even the results object in that change listener is the same object that you already have. So everything is just kind of, it's magic. But because everything's thread confined, unlike SQL where you generally only want one connection, Realm, because it enforces the thread confinement, having lots and lots of connections is fine. So when you get new updates from your server, from your REST request, you just open up a connection, write it to the database, close the connection, and it's fine. So you can, in the app at SQL, we've got heaps of connections just listening to the database, doing different things, and they all kind of work in their own little environments. And you can do this because of the thread confinement, and everything is kind of safe because you can't multi-thread really. The multi-threading is kind of all hidden behind Realm, and with this last dot point, so all the writes block each other. And that's because every time you write into Realm, you submit it a task, and it then serializes it into its own write queue. So even though you're accessing it from lots of different threads, it's internally doing the same thing that you had to manually do before for SQLite and creating that kind of write queue for you. But the write queue doesn't actually block your reads. And the reason we can do this is because of the architecture that Realm implements, which is a multi-version concurrency. So I have this nice diagram that explains that much nicer. So Realm uses this thing called copy on write. So this is, let's just pretend this is our query from before. So when a copy comes in, Realm will actually fork the existence of the database. So it creates what it reckons the new version will be, and once it's sure it's committed it, it then notifies you of the update, and that's what that notification change is coming from. So when this copy on write finishes, it'll then notify you that the data has been updated, but the reference that we had to the root object before is still valid. So we just need to reread the properties that we want and that we know have changed from that change that we saw before. So that's kind of really a quick and rough introduction as to the differences between Realm and SQLite. The talk I'm going to give at Yale digs a bit deeper into how Realm actually works. So if you want to understand how that kind of magic updating works, we can reread the property and how the laziness of those collections can be really severely abused in a way that you can get really good performance out of it, even though the thread confinement means you're doing a lot more work on the main thread. That work is also incredibly, incredibly cheap. So I've got a few more resources I'll throw up on here if anyone wants to have a quick look at these slides later. This is a nice little tutorial on how to use SQLite if anyone wants to kind of work out where I got that SQL stuff from. And the Realm docs are a really good help. So they explain things in really deep detail. If you go to like Realm/news, you can look at some of their like really old articles where they kind of go into really deep detail about how the threading works and how Realm guarantees all these kind of safeties for you. And yeah, so it's my kind of crash course into Realm versus SQL. Thank you all for listening.